Hello everyone, welcome back to our channel. Have you ever wondered how your passwords are stored securely or how websites protect your private data from hackers? Well, the answer lies in hashing and cryptography. Today we'll break it all down, how passwords are protected, how encryption work and real-world application of these techniques. Let's dive in. Before we jump into the technical stuff, let's quickly understand why cryptography is so important. What is cryptography? Cryptography is the art of securing data using mathematical techniques. It ensures that only the intended recipient can access the information. Why is it important? Without cryptography, online banking, messaging apps, and even e-commerce sites would be completely vulnerable to hackers. What will we cover? In this video, we'll explore hashing, encryption, and their real-world applications. Did you know the word cryptography comes from Greek cryptos means hidden and graphenes mean writing, so it combines to hidden writing. Alright, let's clear up an important distinction. Hashing and encryption are not the same thing. Hashing is a one-way process where data is converted into a unique fixed length output. It's irreversible, meaning you can't get the original data back. While encryption, on the other hand, is a two-way process. Data is transformed into ciphertext using a key, and with the right key, it can be decrypted back into its original form. Use casing hashing is used for password storage, as we don't want the other user to know our password, so we want that it always remain in its hash form. While encryption is used for securing sensitive data during transmission in messaging app, as we want that only the intended user to which we are sending our data should decrypt the data back. The first encryption method was the Caesar cipher used by Julius Caesar more than 2000 years ago. We'll start with what is hashing. Hashing is like turning your fingerprint into a unique digital code. Definition of hashing is it takes an input and converts it into a fixed length hash. Even the slightest change in input completely changes the hash. It is irreversible. That means once hashed, the data can't be reversed or decrypted. This makes it great for passwords. For example, the word hello gets hashed into this using MD5. A good hashing algorithm almost never creates the same hash for two different inputs. A rare event called a collision. That is, collision is called when two data have the same hashing. How are passwords stored? Imagine if websites stored your password as plain text. A hacker could instantly steal millions of accounts. So the best practice is salt plus hash. That is, plain text passwords are bad. Instead of websites first add a random value called a salt to your password and then hash it. This prevents attackers from using pre-computed tables to crack password. For example, if you type password 123, the system actually stores something like S5 hash key 3 exclamation marks NK password 123 and then hash it. That is, it adds something in the beginning and then your password and then hash that. Over 80% of hacking related breaches happen due to weak or stolen passwords. Now we'll talk about popular hashing algorithms. So first of all, MD5. This was once the popular, but it's now outdated because it's vulnerable to attack. Then we have SHA-256, which is better than MD5. It is used in blockchain and digital signatures, which is strong and secure. Then we have Bcrypt and Argon 2. These are specifically designed for password hashing because they are slow and prevent brute force attacks. Bitcoin, tra- Bitcoin transactions use SHA-256 hashing for security. Now we'll talk about what is encryption. So definition of encryption is encryption transforms readable data into ciphertext using a key. Without the key, data remains unreadable. Uh, such these encrypted messages are such that it can be decrypted back to original message by same key or some other key. There are two main types of encryption: symmetric and asymmetric encryption, which we will talk further in this video. The Enigma machine used by Nazi Germany was one of the most famous encryption devices cracked by Alan Turing. Now we'll talk about symmetric encryption. In symmetric encryption, there is one key for both encryption and decryption. That is, both sender and receiver use the same key to lock and unlock the data. Example of symmetric encryption is AES, which is Advanced Encryption Standard, which is widely used today. It is used in VPNs for secure file storage and messaging apps. Even a supercomputer would take billions of years to crack AES encryption. Then we have asymmetric encryption. Uh, it uses two keys. A public key encrypts the data and a private key decrypts it. So what happens is that each user has two keys, public and private key. So if a sender is sending message to a receiver, then the data is encrypted using the public key of the receiver as it is public to everyone. But the private key of the receiver is just private to himself so that only the receiver can unlock the encrypted data to decrypt the original data. Examples of asymmetric encryption are RSA and ECC, which are widely used for secure communications. Its use cases are SSL or TLS for secure browsing, digital signatures, and cryptocurrency wallets. Without asymmetric encryption, secure online shopping and banking wouldn't exist. Now I'll talk about real world applications. So first of all is SSL or TLS, that is secures websites using HTTPS, as all the data in the on the any browser must be secured and no attacker should give any wrong data or try to block our data. Then we have blockchain, which hashing ensures blockchain data integrity. Then we have password managers, as our all passwords should be secured, so our password is encrypted and is stored for credential for safety. Then we have messaging apps like WhatsApp and Signal. They use end-to-end encryption and decryption to protect messages. WhatsApp encryption is so strong that even the company itself can't read your message. Now I'll talk about attacks on hashing and encryption. First of all, there is brute force and dictionary attacks, in which the hackers try to guess the password using all possible permutation and combination until they find a match. Then we have rainbow table attacks, in which pre-computed hash lookups to break weak hashing. Then we have quantum threats, in which quantum computers may break today's encryption in the future. Today we don't have any quantum computers, like we don't have any quantum breaking quantum algorithm which can breaks the hash. But in the future, it can possible that today's encryption are break by the future's quantum computers. Some advanced hackers can guess 100 billion passwords per second. So, what are the best practices for security? Always hash and then solve the passwords. Use strong encryption algorithms. Regularly update cryptography protocols. Avoid weak algorithms like MD5 and SHA-1. A 12 character password is thousands of times harder to crack than an 8 character one. So use strong passwords and enable encryption wherever possible. So thanks for today. If you found this video helpful, hit the like button, subscribe our channel and drop a comment below. Ending with a fun fact now, like the longest encryption key ever cracked was 760 bits and it took researchers 2 years.